Starting. Okay. So today we're going to look at solving proportions. What the word proportion means is, it's based off of this word that you're going to hear a lot of times with ratios called proportional. And when we're talking about is something proportional, it means the value of the ratio is equivalent. So like those ratio tables you've made in the past, or like equivalent fractions, that's kind of right in hand with proportional. So starting off with one that you probably can already do in your head to lead us moving forward. So this here, 5/3 is the same as what out of 12? Well, if I'm looking at that, how do we get from 3 to 12? Liam?
3
times 4. So I would have to do the same thing to the top one to keep it proportional, to keep it equivalent. So I'm going to multiply by 4, and then x would be 20. Okay, one thing that maybe you didn't know is when things are proportional, the opposite, we could say like cross multiplying, are going to be equal to each other. So what I'm saying is 3 times 20, that's going to make 60. And 5 times 12, that's also going to make 60. That's telling me, yes, these are equal. That's one thing that's always true about things that are proportional, is my denominator from one and my numerator from the other is going to be equivalent to the denominator of the other and the numerator of the first one. So that's always a check we can do to see if something is proportional. Why I'm showing you this is because we're going to get into problems where you're just not going to be able to do it straight in your head. So the second example I want to show you is going to be using this skill actually here. If I had 10 over 7 and I said, well, that's equal to 4 over what? This is one that you probably can't do in your head. But I know if these two are equal, that this is going to have to equal what 7 times 4 is. So 7 times 4 is what? Help me out. 28. 10 times x is what?
We don't know.
Well, we do know that it equals 10x. 10x has to be the same thing as, because 10 times x is 10x. And then 10x has to equal 28. So 10 times something makes 28. Chris? 2.8. You're totally right. If he didn't just be able to do that in his head, what could he do? How do we solve for x here if it's a multiplication equation? Yeah. Divide. 10x divided by 10 leaves me with just x. And then have to do the same thing on both sides to keep it balanced. 28 divided by 10 is 2.8. X is 2.8. So 10 times 2.8 is 28, and 7 times 4 is 28. Now they're proportional. X is equal to 2 and 8 tenths. Yes?
You can have decimals, like for fractions?
When we're talking about proportions, yes. You wouldn't, if you're dealing strictly with fractions, you would not usually mix them. But when we're talking about ratios and proportions, yes, totally. Let's do another one. So let's say 6.5 over 4 is equal to 8 over x. Well, I don't know what I got to multiply 6.5 by to get me to 8. So I can, cross multiply here. 6.5 times x is going to be 6.5x. And that's going to be equal to 4 times 8, which is 32. Then it becomes a one-step equation. And again, I don't know this one in my head. 6.5 times something gets me to 32. So since I don't know the multiplication, I can do division. So I'm going to divide both sides by 6.5. Now, x is going to equal, we're going to actually have to do this out here by hand. Okay, so he said I got to multiply it by 10 to move the decimal over, multiply it by 10 to move the decimal over. So if I'm looking, 65 is going to go into 320 4 times, and that's going to give me 280, leaving me with 40, which is less than 65, so I'm good to keep going. And I can add a couple zeros. 65 goes into 400 6 times, giving me 390. 6 times 65 is 390. If I subtract, I'm going to get 10. Bring down, 65 goes into 100 once, giving me 65. We'll go one more spot. Then that's going to be 35. Add a 0, bring it down. It's going to go into there 5 times. So x, we'd say, is approximately 4 615 thousandths. So again, this right here would be about 4 615 thousandths. Because this is just going up a little bit, this is just going to be going up a little bit. All right, so you might be wondering, okay, I get it, but what's the point of this when we just have these numbers? Well, there are real-world situations that you guys can use this in. For instance, if I said, I'm just going to write the highlights of this, but if I said 3 burgers cost $25, what is 7 burgers? What's the cost of 7 burgers? So I know we've totally done this where you guys could, one way to do it is find the unit rate, 25 divided by 3, and then get that answer and multiply it by 7. The other way, though, you could set up a proportion. Now, when I'm setting up a proportion, I have to be organized with my information, okay? So what I mean when I'm saying organized, like I need the cost and the burgers to be lined up with each other. So the cost is $25 for 3 burgers. That has to equal, I don't know how much it costs for 7 burgers, so I'm going to put the X there. What I don't know is a cost, so that's going to be an X. Burgers, well, there's 3 burgers goes with 25, 7 burgers goes with an unknown amount right now. So this is how you'd set it up. One other way that would work, I personally like this one, but you could also set it up with burgers on one proportion and the cost on the other proportion. So I could say, okay, 3 burgers to 7 burgers. Well, 3 burgers cost me $25, so 7 burgers doesn't cost anything. It ultimately is the same thing. You'd see I'd multiply 3 times x, 3 times x, 7 times 25, 7 times 25. I kind of like this way better, but they both would work. You just have to make sure you are organizing your information, and we'll look at more, okay? But I would do 7 times 25 is what? You said, how about 175? And that's going to be equal to 3 times x, so that's 3x. To save us, a minute, we could look at 175 divided by 3. And that's going to give me, x is going to equal 58.33 repeating. So it's going to be about $58.33. The store might actually charge you $58.34. So that's another way you could do it. Where else we might see this? Maybe like one of the problems we did for the warm-up today. Maybe you would say the ratio of zebras to giraffes is 2 to 5. And there is 135 giraffes. And we want to know how many more giraffes than zebras. So I could do a table, right? That's what you were taught last year, but I could also set up a proportion. So with my proportion, I'd say giraffes to zebras. And I could say, okay, giraffes is 5 to the zebras is 2. Then giraffes is 135 to, I don't know. This is one where we could just go straight across and you could figure out the length there because 5 goes into 135. But you could also do 5 times x and 2 times 135. So I'm going to do it that way just because it's a newer way for you. 5 times x is going to be 5x. 2 times 135 is 270. Now, I divide by 5, divide by 5. So x is ultimately going to equal 270 divided by 5 gives me 54. So x is 54, right? That means there's 54 zebras, but the question says how many more? So what would we have to do in the end? Subtract them. So I do 135 minus 54. 13 minus 5 is going to give me 8, so we have 81 more. I want to do one last example. The other spot where you might see this is with what's called similar figures. So if I had, and I'll go a little bit slower for this one because I know some of you guys are a little bit behind. So if I had 2 triangles that were similar, that means the side lengths are proportional. Okay? So the angle measures would be the same, but one is larger than the other. These would be proportional. And I know these aren't perfect. I'm going to say this is a right angle here in both of them. So if I said this side was 6 feet and this side was 5 feet, if these are similar figures, then this side I'm saying is 18 feet. That means the relationship between 5 and 18 is the same thing as 6 and this unknown length of this side. So I can set up my proportion with, I'm just going to say the big triangle and the small triangle. All right? So I would say, okay, I'm going to keep these organized. So 5, I'm using the bottom side over 6. This is actually called the leg. And then these sides are matched up. So that has to go on the top. And the unknown side goes with 6 because they're in the same spot. You follow me so far? I don't know how to get from 5 to 18, so I can cross multiply 5 times x, 5x, 6 times 18 is 108. Then I am one step away from solving for the length of this side. I would divide by 5, 108 divided by 5. X equals 21 6/10 feet. So this would be 21 6/10.